Now let's go back and look at the model comparison results. Here here we have the classification matrix numbers. So let's copy paste that here. Okay. Remember, to splice this up, you need to go to data, text to column, and then you can either use fixed width or delimited. So here I think delimited may work better. Yeah, delimited is good. Or maybe fixed width. This okay, so we don't have to. You can keep the model. Alright, so like that. Okay. We don't need any of this. And then we need these 4 numbers. So these 4 numbers and the name of the model, those are the important things for us. So now click finish. Alright, so now I'm going to copy paste these numbers in here. Right? So then we have k equal to, so that will be alright. So now from this we can populate these 2 confusion matrices. So for k equal to 3, so these are the 2. So let's to make it easier for us to differentiate. So how would you populate this based on these numbers? Okay, so the first row is train. Okay, positive will be true positive, so which is that number, right? So negative will be true negative, so which is that number. Okay. Now what is this? This is actual positive. You're predicting negative, but it is actually positive. So that will be false negative. So that will be that number. This will be you're predicting positive, so it's false positive, which is that number. Okay. So now this way and add that way. So now you have the confusion matrix for train k equal to 3. Now you do the same thing here for validate set, so it will be from here. So you have true positive, true negative, false negative, and false positive. Copy these formulas here and copy that formula there. So now you have for k equal to 3, you have both train and validate classification matrix. Okay. Now what is accuracy? Accuracy is the total correctly classified observations. So true positive plus true negative divided by n. Okay. So that will give us the accuracy rate, and 1 minus that would be your error rate. Okay. Sensitivity is among the actuals, how many are correctly, among the actual positives. Okay. Among the actual positives, how many are correctly predicted. So that would be your sensitivity, and specificity is the same thing for negative event. Okay. And the rates, so the rates are for predicted. So false positive rate will be among all the positives predicted, how many are not positive. So that divided by that. Okay. And the same thing for negative. So of all the negative prediction, how many are positive? So these are, copy these here, and now we have the information for k equal to 3. And you do the same thing for k equal to 5 and k equal to 7. Okay, I'll show you the information. I don't know whether these numbers may be slightly different because the validate and the trained sets are separated at random. So you may not get the same answer like what I have here. So if here, if validation set accuracy is your important measure, okay, or minimizing misclassification. Okay, so these two are the same thing. One is looking at it from the positive side, the other is from the negative side. If that's your criterion, then k equal to 3 is better than k equal to 5, and that's even better, that's better than 7 as well. So k equal to 3 is it will be your choice between these three alternative values for k. Okay. On the other hand, if sensitivity, that is, you want to be able to maximize the true positives from the positive, actual positives. Okay. So sensitivity is the important criterion then. So 36.7, 30.4 and 32, and again k equal to 3 does a better job than the other two. Okay. And if specificity is what you're after, then k equal to 5 is better than k equal to 3, and k equal to 5 it gives you better results than the other two. Okay. So depending upon what is important to you, okay, you need to select a particular performance measure and use that as the selection criterion.